The sample test. First of all, if we're talking about something being tossed up and under the influence of gravity, there's two numbers that will show up here, either negative 16 or either negative 4.9. This is half of acceleration due to gravity in feet and seconds. The acceleration due to gravity is negative 32 feet per second squared. And in other words, it gains 32 feet per second every second in speed going down. And if you're in the metric system, it's negative 9.8 meters per second per second. So every second it gains 9.8 meters per second in speed. So this is telling us that we're talking about feet, and the time is in seconds. H is feet, seconds is the time. Okay, so what's the height at 1 second? So there we just put 1 in and we get negative 16 plus 40 plus 10. 50 minus 16 is 34 feet. H of 1.5. So 1.5 squared is 2.25 times negative 16. Negative 16 times 1.5 squared. So that's negative 36 plus 40 times 1.5 plus 10. And we end up with 34. So at 1 second it was 34 feet, and at 1.5 seconds it was 34 feet. And now it says determine the height, the time, where the height is 20. So now we have negative 16t squared plus 40t plus 10 equals 20. So you could subtract 20 from both sides and make it equal to 0 and use the quadratic formula. You could simplify this by dividing everything by 2. This might even factor, but probably the easiest way is to graph the equation. Negative 16x squared plus 40x plus 10. Okay, and if I had Zoom 6, the normal one, it would go off the screen. So to see up there, I would have to make the y values higher. So I'm going to go, say 60. Let's see what that does. There it is. And I want to know when it's 20 feet high. So I can go here and go to y2 and put in 20. And now if I graph, there's 2 times when it's at height of 20. And I can go second, calculate the intersection of this equation, so I press enter, and that equation, press enter, and then press enter, and it finds this one at 0.281 seconds. So this doesn't factor nicely. T would either equal 0.282 seconds approximately, or T would equal, we got to find that other one. Again, I did second, calculate the intersection of the blue curve, the red curve, and I need to find the one over here, so I need to get closer to that for my guess, and it says that one's 2.22 seconds. 2.218 seconds. So this is when it gets to 20 feet on the way up, and about 0.3 of a second, and then at 2 seconds and 2/10 on the way down, it's at 20 feet. And I just explained what those were. This is the time on the way up when it was at 20 feet high, and this is the time when it was on the way down at 20 feet high. And what does h of 1.5, the height at 1.5 seconds, minus the height at 1 second, mean in terms of this? What does it mean? It doesn't ask for the answer. It just says, what does it mean? It means this is the change in height between 1.5, 1 second, and 1.5 seconds. So we put in, figure out where it was at the end at 1.5, and then figure out where it was at the beginning at 1 second. Subtract those two, and we get the change in the height between 1 and 1.5 seconds. Number 2. To the right is a graph of the velocities in miles per hour. Miles per hour this way. And this way is minutes. So here is 60 minutes or 1 hour. Determine V of 30. And this is V, and this is time of the blue car. And the blue car, red car is the horizontal line. This is the red car's line. And this is the blue. So it's just, can you read this? So at 30, what's the velocity? And it is 40. No, of the blue car. The blue car is about 20, 40, 36. 36, this is a situation, you need to put your units, miles per hour, because this was in miles per hour. Determine the acceleration of the blue car. The acceleration is the change in the velocity. Is the velocity changing for the blue car? Well, the blue car is changing, and the change is the slope. So it went from 30 to 40, went up 10 miles per hour, 10 miles per hour in, for the blue car, and this is the blue car, yeah. In 50 minutes. That's the acceleration. change in the velocity over the change in the time. Change in the speed over change in time. That's your acceleration. So it's the slope of the line. Determine the distance of the red car, if D stands for the distance, at 30. 30 minutes into it, the red car is always going 40 miles per hour. So in an hour, it would go 40 miles. But in 30 minutes, it would only get half of that. So it would be 20 miles. What does the intersection of the two lines mean in this situation? It does not mean that they're at the same place. It means the speed of the red car, the velocity of the red car, and the velocity of the blue car are the same. Blue and red car are traveling at the same speed. Page 2. Now, the common mistake for students on reading a ruler is they count the marks instead of counting spaces. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 sixteenths inches. Okay. So, if we're going to fold that paper like we did in class, then the height of the box will be however much we fold, and they told us that was 2 3/16. And so we have to take 2 3/16 off of the width, 11 inches. We have to take it off twice. So I'm just going to figure out what 2 3/16 plus 2 3/16 is to figure out how much we have to take off. That'd be 4 6/16. 6/16 reduces to 3/8. So 4 3/8. So the length, 17 minus 4 3/8. 17 minus 4 is 13. So it's 12 5/8 plus 4 3/8 is 17. Width, 11 minus 4 3/8. With 4 off 11, 7 minus 3/8 more is 6 5/8 inches. Don't forget units. And the height is going to be just the width of this that we fold up, which is 2 3/16. And the volume is going to be those multiplied. So it's going to be parenthesis 12 plus 5 divided by 8, or 10 divided by 16, times parenthesis 6 plus 5 divided by 8, times 2 plus 3 divided by 16. That's 182.96 cubic inches, or inches to the third. Write a formula for the volume using x. The volume, as a function of x, is the length minus 2x's, the width minus 2x's, and times the height, which is just x. Or for this case, the length, which was 17 minus 2x, and 11 minus 2x, and x. Now we're going to graph that. So we're going to go here and go parentheses 17 minus 2x, close parentheses, open parentheses, 11 minus 2x, close parenthesis, open parenthesis, and x. And if I push graph, it goes off the screen. It crosses at 0 in the x, at 1, 2, 3, 4, 5.5 on the x, 6, 7, 8, 9.5. 8.5. 1, 2, 3, 4, 5.5, 6, 7, 8.5. 6.5 and 8.5. And at 0. Those are the intercepts. I'm just remembering that. Now I got to find the maximum volume. Well, this graph comes up and it reaches a peak in there and comes back down, has a low spot and back up, just like we saw in class. So the max is somewhere between 0 and 4. So second, calculate the maximum between 0, enter, and 4, enter, and I'm going to guess 2, and it says 2.1778. 2.1778 inches is the x that yields the maximum volume. Determine the maximum volume. So we would then get this number, 182.96666. 182.97 inches cubed, cubic inches, either way. Describe how the x-intercepts are related to the box. Well, 0, when the graph was at 0, the volume was 0, and that's because if we don't fold up any side, we don't get any volume. 0, no folded up sides. No sides folded up, I should say. 6.5, that's folding the width exactly in half. So there would be the width of the box would be width equals 0, so there would be no volume. And the 8.5 inches is when the length is folded in half. So again, there would be no width, or length. The length would equal 0, so they'd have no volume. That's what those x-intercepts are telling us. So for this situation, the only side folding that makes sense is to do something between 0. 0 wouldn't be folding in a box, so we'd have to do more than 0, and up to 6.5. And we probably wouldn't want to do 6.5, and so we'll leave it that way. But you can put a square bracket if you want. We could fold it up to 6.5, but we'd get 0 volume. the situational range. Okay, so what values do we get out? Well, we get heights, or volumes in this case, volumes that go from 0 clear up to 182.96 or 97. So it goes from 0, we wouldn't have a box if we had a height of 0, up to 182.97, and that's the range. And it looks like it gets to there, so we could include it or not include it. It might not quite get there, it gets really close to it. We'll count it as solid, but it doesn't have to be. All right. Now here, we're pouring water into these vases. And if you're pouring the water into the vase at a constant rate, let's see, vase at a constant rate, what's the height going to do? Well, in this kind of vase, if you pour it in at constant rate, like if you put it under the faucet, the level would rise constantly till it got full. If you put this one under the faucet, since it's smaller here, it's going to fill up faster at the beginning and then slow down till it's full. On this one, it's going to be a little bit faster and then slow down, and then when it gets to the neck, it's going to speed up at the end. It gets wider here at the beginning, so it's going to slow down as you go up. It's going to fill fairly fast at the beginning and then slow down, and then when you get in here where it's getting smaller, it's going to go up faster and faster. And that's those graphs. Distance time. This one has the time, and it would be the time, the number of hours, times 50, because you go 50 miles every hour, so if you take it times the number of hours, you get the distance. Distance depending on the gallons. Well, this is the miles depending on the gallons, so it would be for every gallon you go 30 miles, so 30 G, and we want a function G. Gallons for distance, that's the inverse of this one, so we got to undo this one. So another way to get that is to say D equals 30 G. We want to solve for G, so we divide by 30, and we find out G is the distance divided by 30 gives us the gallons. T of D, so we have to give it D. This one takes D and changes it to G. And we need something that'll change G to T, or not use that one. Now, this says D of T. Could we do T of D? Well, see, that would be this one working backwards. So we'll do what we did before. We have D equals 50T. We're going to solve for T, so we'll divide by 50, and we get the distance divided by 50 miles per hour will give us the time. So now we need a function that we give it T and we get G. Well, this one takes T and makes D. Do we have a way to give D and get G right there? So we have to put 50 times T will give us a D according to this one. And when we have D, we divide it by 30 and we get G. So here's G of T. All right, domain for this. Square root can't be negative. 4 minus x, go up to 4 with a slope of -1. That looks like this. and we have to have positive numbers in there. So it's positive when we have numbers from negative infinity up to 4. The line is positive. After that, it's negative. So we're going to have to go from negative infinity up to 4. We can use 4 because we can take the square root of 0. So there's the domain. This one, you can't divide by 0, so x can't be 3 because 3 minus 3 is 0. So we can have from negative infinity up to 3, but not including the 3, union, and then go the rest of the way, 3 to infinity, not including the 3. Or we could say all reals except 3. This one, we can't divide by 0, and we can't have square roots of the negatives. So 2x looks like a slope of 2 going through 0. So we can't let it be 0, and it can't be negative, so we don't want any of this part, so it's going to be, and we can't let it be 0, so we're going to go not 0, but any numbers bigger than 0, that is positive. This one, we have to be able to put it into F, so it has to be restricted to this, but then we have to be able to put it into R. So, of these numbers, do any of them produce 3? Well, if this was 0, this would produce 3, and 3 minus 3 would not be acceptable, because we have division by 0. So 4 is what made it be 0 in here, which made this come out to be 3, which we can't use, so we can't use the 4. So this becomes negative infinity up to 4, but now we can't use 4. Now this one, this is tricky. So if I put x squared in here, let's take a look at that. Graph clear. 4 minus x squared. Now, you may know what this looks like, you may not, but I'm going to go zoom 6. And we have to do the square root of positives. And if I'm putting x squared in place of the x, I have 4 minus x squared, and it has to be positive. Well, it's positive from minus 2 to 2. It can be 0, but it can't be negative, which it is over here and over here. So we have to say we can only use, we can use minus 2, because minus 2 squared is 4, and 4 minus 4 is 0. That's okay. Up to 2. 2 squared is 4. 4 minus 4 is 0. We can use those, and that's it. Okay? Okay, so write a function h of s, where s is seconds, and h returns hours. So h of s means it gets seconds. So if it's 120 seconds, to turn it to hours, we have to divide it by how many seconds there are in an hour, which is 3,600 seconds make an hour. So that's h of s. Takes the number of seconds and turns it to hours. So now d of t founds the miles it went, which was the velocity of time. So d of s, where distance is mile and velocity is in miles per hour, and now we want d of s of the composite, so we want to do, it's going to be v of t, but t is in hours, so we have to convert t to s, so we have to go, for the t, we have to make it s divided by 3600. Or, if you will, V of H of S. Take the S, convert it to hours, and then put the hours into velocity, and you get the distance. And that would be now, since the variable is S, this is d of S. Before it was d of t, but we changed the t to s, so this becomes d of s. 9. Determine f of g of 1. G of f of 1. So put 1 into f. So 4 times 1 is 4 minus 3 is 1. So this comes out to be 1. And if I put 1 into g, here's the x's, there's 1, and g produces 0. This says put minus 2 into h and minus 2 into g and add the answers. So h of minus 2 plus g of minus 2. H of minus 2 is 1, and g of minus 2 is 3. 1 plus 3 is 4. Find x where k of x equals 3. So the y value on k, here's k, is 3. Y value is 3 when x is 1. Put 0 into g. 0 into g is 1. So now we have to do f of 1. 1 into here is 4 minus 3, which is 1. So we have to do h of 1. And h of 1 is 2. So now it says find the inverse of f. So that's when you take and switch, this is the y, it's like y equals 4x minus 3, and we want it to go backwards, so we want to switch the x and y, so we're going to write x equals 4y minus 3, and then solve for y, add 3 to both sides. X plus 3 equals 4y. Divide both sides by 4. And we get y is 4x plus 3 divided by 4. Now, what that means, in case you're not clear yet. For example, if I let's put in 2 into f. What do we get? 2 times 4 is 8, minus 3, we get 5. So in the inverse, I should be able to put 5, so 5 plus 3 divided by 4, and I should get back to 2. The inverse takes us back. 5 plus 3 is 8, divided by 4 is 2. The inverse takes the answer we got for just the regular function and takes us back to the original x. That's what an inverse does. Since g is just listed, the inverse is the table backwards. So the x's become what the g's were, 3, 2, 1, 0, minus 1, and the g inverse of x goes back to the x's, which were minus 2, minus 1, 0, 1, and 2. They took us back. H inverse would be the same thing. So the x's would be what we got out, 1, 2, 3, 2, 1, and go back to h inverse of x, go back to the original x's, minus 2, minus 1, 0, 1, 2. However, this is not a function because they can put 2 and we get 2 different answers, or 1, we get 2 different answers. So we have to use our knowledge here and say, nope, this is not a function, so you can't do the inverse function. Can't do it. And now we've got to do f inverse of g inverse of 3. So we go to g, find 3, and go backwards, and we get minus 2. And then we have to do f of minus 2. And 4 times minus 2 is minus 8, minus 3 is negative 11. And finally, to graph inverses. This point is 4, negative 4. 4 in the positive x, negative 4 in the y. So on the inverse, we're going to graph, and I'll do this in a different color, we're going to graph negative 4, 4. Negative 4, 4. So this point gets moved up to here. Negative 4, 4. All right. Where does this point go? Well, it's about negative 2, negative 2. Well, negative 2, negative 2 switched for the inverse is still negative 2, negative 2. So this point stays here. So the line that went from here to there now goes from here to there. And where does this line go? Well, this is negative 4, 4 originally, so it goes to 4, negative 4, so this point gets down here. So we have this goes to here, and where does this little curly piece go? Well, that is negative 7, 5. So that's going to go to 5, negative 7. Notice I'm swapping the coordinates. And to make it come off of this, bend right away and then go straight, I'm going to have to bend right away and go straight. So it goes here and here. So the inverse, most of it lies right on top of what we already had, and this part gets put down here. It's a reflection over y equal x. The original black one goes to this red one, where this gets flipped over to here, this gets flipped over to here, and this gets flipped over to there.